All right. I think that we're all set here. Recording. That's good. Okay, so today we're going to do, did I write 6 or 5? This is 6. Today we're going to do week 6. Sound keeps like fluctuating down there on the coast, but today we're basically going to talk about ArcPy again, but we're going to discuss how we could take a script that we created and put it into ArcGIS as a toolbox. So who's used a toolbox before in ArcGIS? Hopefully everybody. If you took 418 last semester, we kind of covered creating a toolbox using Model Builder. Now, you don't have to have done that before, but has anybody done that here? Use Model Builder to create a toolbox? Okay. So this is another way to create a tool. And sometimes it's easier to create a tool using Model Builder if it's a simple tool. If it's a complex tool, you can create a tool in our toolbox using Model Builder or a Python. And what's really nice is that you can actually create tools and then chain them together using whatever you want. So you can write tools within tools. And your tools can be a combination of Model Builder built tools and Python built tools. It could be either one. I'm going to open up ArcGIS because we'll need it today.
Dr. Raber?
Yeah.
Could you change your camera so we can see you?
Oh, yeah.
Please?
Yeah, thanks. Camera's pointing outside. Probably not in the direction that it's pointing in.
Hey, there you go. Thank you.
Leverage in there.
Yeah, climb up on the furniture to do that.
For some reason, yeah. For some reason, the camera does have controls here, but if it gets too far off, eventually it stops responding. And so, like, if it gets pointed all the way in one direction, it'll quit. And then you have to get on top of the furniture. What about y'all? You have to do that sometime?
No, it seems like it always works.
Oh, really?
It does sometimes just self-aim to the ceiling.
That doesn't sound like it always works, though. Am I focused?
Yeah, looks good.
Okay. Cool.
Thank you.
Oh, no problem. So this is our toolbox, which we all know. And I did kind of talk about this last week, but there are, a number of tools. Anytime that it has that little rolled up scroll, it's a script tool. So we're going to learn about how to do that today, how to create those. And what we're going to do is first talk about why it works and basically how it works so that you understand that, because that does help you when you're actually trying to run these things. And then when you chain tools together in Model Builder, there's this concept of an input to a tool and an output to a tool, right? Like if I I don't know, I'm going to create a new toolbox because I'm going to need it later, but this will just be for fun. I'll put it in C temp, and I'll just create a new toolbox. I'll just call it test for now. Add that. And then take test and add a new, right now I'm not going to do a script tool, I'm just going to add a new model. But if I go in here and I go to, what's one of the ones we ran last week? We ran intersect. So I take intersect, take intersect and I drag it on there. Notice that by default, here's the intersect tool which will run, and then here is the intersect tool's output. So we've got outputs, and then we can see the inputs if we double click on a tool. See the list of all the inputs there, right? There's the list of inputs. This is another input. These are all inputs, right? Now, if I want to, I can right click on any of these and say make variable from parameter input features. So now I have a little circle that represents the input. If I double click on it, I'm specifying just the input there. This is the data type that it is. It's a value table. There's literally hundreds of different data types. And we don't need to learn about them all. Okay? In the end, when they actually get run, they're all converted into a Python data type. So we know that this is actually converted into the list. All right. Does it sound like something's going on the coast? Yeah. Is it windy down there?
No, are you getting feedback?
There's some. Well, now it sounds gone. Like it's gone. We were getting a blowing noise.
It was sitting on a tower, a PC tower. I wonder if you were hearing the thing.
Oh yeah, maybe so. All right. Okay, so that is just a brief overview of Model Builder again. And so one thing that we're going to do first is I'm going to hit the Windows key and type in CMD. This is going to open up the command prompt. You can do this too if you want. All right. Now, see what happens if you just type Python on your computer. Does it do anything? Does it open Python? On the coast, does it do the same thing?
It says not recognized.
Okay. So this is something that you have to set up on your computer. And this isn't necessarily super important today, but this is getting to why it works. So I typed in Python. This is I don't think you can change this on your computer, but this is what's called an environmental variable. So if you went to I don't know how, oh, there it is. Edit system and environmental variables. If you went to environmental variables, you'll notice that in the one called path, I don't even know if it'll let you open these up or not. Sorry, it's not there. It should be system variables. I'm not sure why this is working on mine, but that's where. Oh, so system variable path right there. There it is. Okay, so under system variable path, if you hit edit, there's a list of all these directories. And you'll notice that Python 2.7 is there on this screen. You may not see it. It may not let you open it on your screen. Did anybody try? Does it let you open it? It doesn't let you open it.
I do it at home though, so I know what you're talking about.
Yeah. So if you set this right here, see Python 2.7 ArcGIS 64 10.4. That's the directory that the Python executable is in. If I go to that directory, C Python 2.7 ArcGIS 64 Python exe. So that's the actual program that runs Python. It's just a program. That's the Python interpreter. So when you send it a Python script, it works and it runs. You can open it but not edit it on there. Yeah. Now you probably, it sounds like if Python works, so basically if you put the path to any of your directories and there's an executable in that directory, it will allow you to reference it from anywhere. That's the purpose of the path directory. So if you don't have that, the only way to execute Python is to get that path, whatever it is. So anyway, I'm in Python right now. See how I can import ArcPy. It's going to take a few seconds, I guess, because it's kind of trying to license it. Okay, and I could run a Python statement. It's just like being in Python. Okay, I'm going to quit out of it, or exit, I guess. Or, there is a space in between import and ArcPy. Yeah, okay. So the operating system can handle that phrase Python anywhere in this scenario. Okay. But alternatively, if I actually copied this, and yours is probably in a similar location, so let's see if anybody can do this. I'm going to type in CD and then the full path to Python. I might need to put it in quotes because it's got a space in it. See, for me, it's not going to let me paste it. So I'm just going to type it. C:/Python 2.7, no, just 2.7, no point, /ArcGIS x64, there's no space, I guess, x64 10.4 for me. It'll be different on a different computer. I don't really need to put it in quotes. Let me try without quotes. Still can't find did I spell something wrong? Python 2.7 /ArcGIS x64, not x65. There we go. All right. So now I'm in that directory. So if you find the directory where your executable say, it's probably almost the same except for instead of ArcGIS x64, this part might be different. Okay. And then now you type in Python, it should work for everybody. Does that work for? I mean, you guys could just type Python, it sounds like up here, but on the coast, what's that? And again, we don't need to do this today. I'm just demonstrating why something works. So if it doesn't work for you, it's not a big deal. I should try to make this bigger. Let's see if I can. I don't know if I can. All right. So the next concept. I just didn't spell quit right the first time. Quit does work. So the next concept is that you can actually execute a Python script and feed it parameters right from the command line. The command line, all it does is take commands and dispatches them to the operating system. So if I type in, well, first of all, let me create a script. let's go back to ArcGIS. I mean, to IDLE. I go back to IDLE and create a very simple script. Or maybe I could just use one that already had one, but let's just create a new one. I'm going to create a simple script that just adds two numbers together. So I'm going to write input, or sorry, that'd be raw input. Well, I'm just going to hard code them. A equals 5, B equals 10, and then I'm going to write print A plus B. I'm going to save this. I'm going to save it in C temp. Actually, I'm going to save this in C temp SPA week 6 and call it example, or 2018 example 6 or 6_1.py. All right, now I could run it from right here, and I get 15, right? That's 10 plus 5. But I can also run it from here. It's easiest to do this from the directory that you're in, because then you have to give the full path to it. So if I go to cd c:/temp/spa/ what do they call them, M6, yep. And then I type in dir. These are all the files in that directory in M6. And you can see the one I just made, 2018 example 6_1. I'll turn the light off. You all can turn the light back on when we get in later, but it might be easier to see. Nope. Not easier to see. So the file that I just created is right here. So if I type Python, py, and then type the name of the script, 2018 _ example _ 6_1.py, and I press enter, it prints 15 right there. So I can run a Python script from the command line. This might be useful to you, like if you had a Python script that you wanted to run on startup every time, or if you wanted to run a Python script every day at a certain time. You know that the operating system can handle you running a script right to the command window. Just the operating system can handle being sent a script not that ArcGIS runs on Linux, but Python does, and you don't have to even set up a path variable there. It'll just run. But so we've just created that. Now, this is what's going to allow today's stuff to work. Okay, and again, you don't have to follow along, but if you want to, that's fine. I'm just trying to explain what's going on when you send a tool into the toolbox. All right, I'm going to get rid of A and B right here. Okay, I got rid of it. Okay, so I'm going to say import sys, and this is a system this is a library for handling or working with the system. Okay, and then I'm going to say A equals sys.argv and say 0. And then B is going to equal sys.argv1. So these are things that are going to be sent in when the program runs. It's kind of like our program becomes a function, and these are the two arguments to the function. And you have to just give them in order. So the first one will be 0, the second one will be 1. Now, by default, everything's passed as a string, as text. And so we do have to do something. We have to convert those to a float. So now, those will be converted to floats, and then it's going to print the sum of those two values. So I could save this. If I try to run it here in ArcGIS, I'm going to get a problem because it doesn't have a sys.argv0. There's nothing there, and so it has trouble converting it to a string. To a float. Okay, but if I go back over here, first of all, if I try to run it the exact same way, I'm going to get a similar error. However, I have my command right there. If I type space and then type 5 and then space and 10, now I have the ability, I'm passing in 5 and 10 into my script. So when I press enter, it still didn't work. Yeah, when I press enter, I should have added them together. I'm spelling it right. sys.argv. I'm going to modify my script slightly so that it's going to just print. Let's build the script up. So it's just going to print A and then print B, and I'll see what my problem is. Or it's going to print A first. Oh, I know what it is. Sorry. And you'll see why I was confused in a second. So the first argument, I'm going to comment out this. Look at the first argument is actually the name of the script itself. So the first argument is the first thing that Python got, which was the name of the script. And so that's the one that's the 0. So 1 is going to be the next one, 2 is going to be the next one. All right, so I messed up. Sorry about that. So when what we want to do is say 1 and 2, and then we want to float those guys, and we want to float this one. Now it should work. Plus B. Let's save it. It's still going to fail trying to run it in here because it doesn't have a second a second argument. However, if we feed it to it in here, it will add 5 and 10. And we could run it again with different numbers, and now we get 16. This says 15, this says 16. And so we've succeeded in passing these values in. So we run a Python script, and we've given it 2 values or 2 arguments. We gave it 3. We gave the name of the file. That's always passed in case you want to reference which file is running. Okay? But then any other, what we call command line arguments, that's what they're called. Any other command line argument can be referenced from there on out. So why would that be important or exciting to be able to do? What could you do with the command line argument? You could write a script that did anything you wanted to, but command line arguments are a way to do what? Yeah, input data, so you can have different variables. If we go way back, like, I don't know, Well, it's not bypassing Python or Arc. It's still running both if you're running ArcPy, but what allows you to do is I'm just trying to find one of these earlier ones. What allows you to do is get a value right from the command line. That just but anyway, what I'm trying to find is one of the old scripts from earlier that had a raw input value as the input. And instead of doing raw input, you can actually get your inputs right from a command line argument. So you could feed it 3 lengths of a triangle, and it can figure out if there's a triangle and print it for you. So where this is going is that this is actually what's happening in the background when you dispatch a tool to ArcGIS. When you set up a tool to run in Toolbox, what's happening is when it actually runs, ArcGIS is handing it off to the operating system, and the operating system is passing in those other values as command line arguments. It's passing in all the other values, whatever else you're feeding it. So if you're giving it a list of layers, last week we gave it some layers, it's feeding that as a set of sys.argvs into the system. We could actually, at this point, we could make this a toolbox. However, if we did that, right now there's no way to return that back to the user. We also need to learn how to do that. So this would print, but you wouldn't actually see it being printed. Where would it print to? We wouldn't. There's no console in ArcGIS, so we need to learn a few things about that before we continue. So, all right. Let's just, in order to continue, the first thing that we're going to do here is build a script that basically just adds 2 numbers together and make it a tool in our toolbox. And that way we'll learn what the basics of how to build a tool. Okay, and then we can build that into a more complex example. All right. So if this is a tool that we want to build in ArcGIS, we do need to import ArcPy. That's one of the tools that we need to have. Interestingly, we don't actually need, I'm going to save this as example 2. We don't actually need to import sys because ArcPy has a wrapper that it actually protects us from having to use sys directly, and it puts it inside of ArcPy. It has a different function that we call to get the parameters out rather than ArcPy. So we can delete that text. So we just need to import ArcPy. All right. Back over here, this get parameter as text is the function that we want that will do the same thing as sys. So if we go like this, search for it, we can see that this is the function here, get parameter as text. And we can get the very first parameter is 0, the second parameter is 1, the third parameter is 2, and so on. So that's why I got confused. So sys.argv, the first parameter, which is the file name, is 0, and the first parameter is actually 1. Well, in ArcGIS, it doesn't work that way. The first parameter is the first thing after the file name. All right, so we could go like this. argpy.getParameter as text 0, and argpy.getParameter as text 1. So what we're doing here is we're asking, when this runs, ArcGIS is going to pass in some parameters, and we're going to get the first parameter and store it in a value called A, and the second parameter we're going to store it in a value called B. Okay? We're going to save those. Oops. Now, there's a few other things. One of them is that we can use ArcGIS to get the argument count. Okay, we could find out if 5 arguments were passed in, 2 arguments were passed in, 3 arguments were passed in. I'm going to just put that in there, right here. Oops. So now I'm going to get the argument count. I'm just going to print it out onto the screen. What would be the utility of that? Why would we even care how many arguments were passed? Have you ever run a tool where something is optional? Yep. So if you can get an argument count, you can find out how many arguments were passed. And the optional arguments are, you should set them up so that they're at the end. So you could say, if there's only 3 parameters, do this. If there's 4 parameters, do this. 4 arguments, I mean. So that's the utility of get argument count, is to be able to handle tools that have an unusual number of, a different number of arguments in different situations. Sometimes they have more, sometimes they have less, depending on whether something is optional or not. All right, so I'm going to set this up to run as a tool. I'm going to go ahead and save it. So this is called example62.py. And what I'm going to do is, I'm actually going to get rid of this one, but I'm going to set up a very similar one. So I'm going to get rid of test, and I'm going to add a new toolbox, and I'm going to put my new toolbox in the directory I'm working in. C, temp, SPA, week 6. Right? That's where I'm going to put it. And see, I already have one from 2016, but I'm going to create one called 2018, week 6. Oh, oh no, wait. I did that right. Add toolbox, but you got to hit this little button right here that says new toolbox. So I'm going to create that new toolbox, rename it. Now I have it. It's empty, but I have it, and I can hit open. So now I have my 2018 week 6 toolbox right here. I've got it, it exists. It doesn't have any tools in it, it's kind of a boring toolbox. I could drag in other tools if I wanted to. You can make toolboxes have tools that are in other toolboxes. I could put identity in there, but I'm not going to, for example. Okay, so in order to add a model, you go down to new model. But what if you want to add a script tool? Well, you go to, instead of new, you go to add. And then you hit add script. And you get this dialog window. This is actually kind of like a wizard. I don't know if wizard's still a term that people use. But a wizard is usually a graphical user interface that you step through. That's the term for it. So we've got our window here, and we can give the name of this tool. We can give this tool a name. Now this name, the thing that right here that says name, that's what's going to appear here. See how symmetrical difference appears and there's a space? The name can be text and it can contain spaces. It can look however weird you want it to look. So you can type in a name with a bunch of spaces. I'm going to call mine add numbers. Okay, got my add numbers tool and I've got a space there. And that's okay. Oh, sorry, other way around. Add numbers actually goes here. The label can have spaces. Control X. The name can't have spaces. So I'm just going to call it the same thing, but I'm going to write it in camel case, where I've got the first letter of each important thing capitalized. So add number without any spaces. So that can't have spaces, the name, but the label can, and the label is what shows up here. So I was wrong. Then you could type a description. A description will help people to be able to utilize your tool well. You can type a description. I'm going to leave that blank. Okay. A style sheet can help with the layout. I'm also going to leave that blank. In fact, I rarely use that because ArcGIS does a pretty good job at laying it out. So I'm going to leave description, style sheet blank. These next two are important though. Okay? The next one says store relative path names instead of absolute paths. There's a very similar checkbox when you go to save a map document, right? What does it mean in a map document when you check that box, store relative path names? Do you know what that means? What's that? So in this case, I mean in the case of a map document, it's where the data is stored. You store data, and so if you check that box, it says okay, relative to the map document, where is the data? So is the data one directory up, or is it two directories up? Whereas if you leave that unchecked, it'll go C:/whatever. The reason that this is important is because the .py file, the Python file that's running the script, and the toolbox file are two different files. They're not the same file. And so if you click store relative paths, you have to move the Python file and the toolbox file together to different places. And some people like that. I like that. I like to store my scripts together. In fact, sometimes I put them in a directory just below. So I'll create a toolbox, and then all the scripts that are needed for that toolbox, I'll put them in a different directory called scripts. I'll put them all in there. And then I can move the toolbox file along with the scripts file anywhere I want. And that's a way to stay organized. Some people leave this not checked, and then they can take the toolbox file and move it anywhere on their computer. They could decide, oh, I want it in a different location now. I want to put this toolbox file over here or over there. And you can leave the scripts file where they lie, because it's an absolute path. In other words, the path that the toolbox file is storing for the script file is like C:/temp. It's storing the whole thing. So you can move the toolbox file wherever you want, and it can still find the script file there. So can you see, okay, which one, that's a good question. I mean, better question than I was going to ask. Maybe it's still not a good question. Which of those two choices would be better if you wanted to take your script and share it with some other user that was on a totally different computer than you?
The relative.
Yes, the relative.
Yeah, so like if
Yeah.
the tools.
So that way you give them the tool and the script together, you pass it over to them. Okay? Because if you didn't check this and you pass it over, both the toolbox and the script over to them, they would have to store it in the exact same path that you had it stored in order to utilize it. So if they didn't have a C:/temp/SBA/week 6, then it wouldn't work for them, because when you ran that toolbox, it would say, I can't find that script. It actually wouldn't even allow you to run it. It does the same thing that it does over here. It puts a little exclamation point, a little red exclamation point next to it when it can't find the script. Okay. All right, so almost always I check store relative path names. Okay. That way, you can easily share it. They still need both the toolbox and the script file. There's nothing you can do to get out of that. They still need both of those data. But either way, they would need both of that information. Unless the exception to this is like, let's say you worked in like an enterprise system where everybody stored their scripts up on some shared directory, like a network share. And that network share was always mapped to the same path on every computer when you logged in. So if you logged in on this computer or that computer, there was a network share, like an X drive if we're using Windows. It was always the X drive on both computers. Then it would be okay to just share the toolbox around. But anyway, so that's store relative path names instead of absolute. That's what I choose. So I hit next. Next, you have to choose the script file. The script file is the .py file that you created. In our case, I put it in C temp SBA week 6, and I called it 2018 example 2. So now I've got that path. Okay. So it's important that you choose the right file. And then, I forgot to say what this one does. Always run in foreground. So what that does is if you click that, and that's a good thing to do, at least until it's good to check this box, at least until you've run it a few times, and you're confident that it works well. If you don't check this box, you won't get the little window that comes up that tells you that it's running. It'll only appear over in the results, and it'll be running over there. And so it's just easier to see the result. Okay. All right. Just leave the rest of these defaults almost always. All right. This is where you set up the command line arguments that are going to go in to Python. So this is where you feed it the variables that you want to change inside your script. So your script is going to take a number of inputs. In our case, we're just going to, for this example, we're just going to take 2 numbers. And we can name them whatever we want. But you have to realize that this number, this display name that we chose, that doesn't get passed into Python at all. That's purely for the information of the user of the script. So I just called this number 1, this number 2. So that's, the user's just going to see that. They're going to see that when they go to run your script. They're going to see number 1 and number 2 there. Okay. All right. Next, we need to feed it a data type. A data type is the type of data that you want the user to be able to choose from. Now, all your values are actually going to be passed into Python as strings, but if you choose, for example, a long, the user's only going to be able to select a number that's long. It's going to do the error checking for you. We're going to click float for both of these, or actually double. I don't think float is one of the options. Maybe it is. Let's see. Float. No. So double. We're going to click double. I don't know why it keeps going in and out. Do you see double on there? Double. We're going to make both of these a double. Now this screen you can always get back to. In fact, you can get back to any of those screens. So even though you went through 3, you can get back to any of these screens. So if you mess up, you can come change it later. Double. All right. So I made both of those a double. Now also, you notice that down below there is a number of another parameter properties. Okay. The first one is that this is that basically just says whether it's a property or not. So that's, you rarely change that. The type is whether or not it's whether or not it's required or optional. Or a third one is derived. Derived means that the user doesn't get to specify it at all. It gets created by the script and it gets input into the value. So derived are almost always output variables. Is there something loose? Anyway, so for inputs, it's almost always either required or optional. I'm going to choose required. The user has to type it. For both. See when I change these change right here. You can change the direction, whether or not it's input or output. In our case, both of these are going to be input. We're actually going to create a new number, and we're going to call it the sum. Okay, that's a new parameter. We're going to create a new parameter called the sum. Now the data type there is going to be a double as well. See how that's a double? But the type is no longer going to be required. We don't want them to enter the sum. We want to tell them what the sum is. So we want to put derived. In other words, our script is going to create the value, the sum, exactly. Okay? And notice that it automatically switched to output. I don't know if we can change it or not. I don't think we can. Okay, you can. But almost always, derived will be output. I can't actually think of a scenario where you can make a derive an input. So, I've never made it an input, but I like it how it switches. All right, so we talked about type and direction. Multi-value, sometimes you want the user to select or to create a bunch of different values. And you want the user to type in a list of values. In fact, when we ran Dissolve last week, one of them was a multi-value. Remember, we could give it a list or whatnot. Okay, you can give it a default value. That might be interesting for these two. Like, let's give these a default value just to show how it works. We're going to give this one a 5 and this one a 10. So now those values will be the defaults when we go to run the tool, which we will in a second. Okay. Then the environment, you could set up some environments beforehand. We don't need to do that yet. A filter allows you to, well, it's not going to work for derived, but for an input, the filter allows you to specify either a list of values or a range. So if you wanted to limit the user to selecting a number between 1 and 10, or like let's say your number represents a month, you could specify and tell the user, I want the user to only select 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So you could choose that as a range. So they can only select 1 to 12. I'm going to put that in there well, I'm going to say none. Because it's a float, so there's going to be any number in between there. But that's what that filter does. You could also use it to specify a list, like they could be high, medium, and low, or any list that you wanted to make them select a value in there. All right. Now, the obtained from, we're not going to cover symbology. Symbology is like if it was running as a tool and it was a feature layer, you could actually choose the symbology that you gave it at the end. So you notice how when you run some tools, maybe you don't, but there are tools when you run them, at the end, they always are symbolized the same way. Like they may be symbolized on a red to blue range, right? So that's what the symbology. You can feed it a layer file, and it will always give it the same symbology at the end. Okay. All right. Obtained from is we will cover this. We'll cover it better in a second. But basically, what if you chose first a shapefile, and then you told them that you wanted them to select a field, but it had to come from that shapefile. That's what obtained from does. So right now we don't have anything that would work with that. But the second example that I'm going to go through today, we'll feed it a shapefile and then we'll have it choose a field from that shapefile. So here you would choose the variable that contained the other information. All right, so that's what that does. So now I'm going to hit finish. So now I have my tool, and if I double click on my tool, see how number 1 and number 2 show up. Those are the names that you gave them. The script will never see those, but those are the names that you gave so the user would be able to know what these were. And then 5 and 10, those were the default values that I put in. And if I say OK right now, it actually is going to attempt to run my script that I have. So I'm going to run it, and it actually did complete it. So it ran add number, and it completed add number. It actually took 1/100th of a second to run. It was a really easy script. But I don't see the result anywhere. It didn't actually finish running, and that's because we need to feed the result back to ArcGIS for it to get the result. Okay? So in order to do that, we can go back to our script, and instead of trying to print it, printing it is not going to work. We need to do the opposite of get parameter as text, and we need to set parameter as text, and that will take it'll take any argument, it'll convert it back into to a string and feed it back to ArcGIS. So that's just going to copy this and say set parameter as text. Now, let's see if anybody can figure out this. What number do I need to feed it? I do need to feed it this, but I also, which parameter number would it be? 2. And that's right, it is 2 because 0 was number 1, 1 was number 2, and 2 is the next one down, which we call the sum. So we need to feed it 2. And then the second value, this function takes 2 parameters. The second parameter we need to feed it is the sum. So we can put A plus B. And I actually forgot if it cares that that's not a string. So I'm gonna try it out, see what happens. I can't run it in here anymore. Well, I can, but it won't work. What's that? Well, I could. It might be better practice to go C equals A plus B and then put C over here. But it'll actually do that math. It'll do that math before it assigns it out. So those are equivalent statements. But you're right, this looks a little bit better. This one won't work in here. Well, I guess it is running. Probably because it's just getting zeros for both of those parameters. So it's not really working, but it didn't produce an error. But if we come back in here and we run this guy again and I say okay, let's see, if I go to geoprocessing, processing results, oops, and I expand it, the sum right here, it says 510. What can I do to make sure that I get the right number? Now, why does it say 510, first of all? It added 5 and 10, but it added them as strings, right? So I need to write float here. So now I'll get the correct number. File, save. I can rerun it like this. Completed. I've forgotten, it does say 15. I've forgotten whether or not it was okay to just feed it it is. To feed it a non-string. ArcGIS actually handles it. So ArcGIS is actually running some code that's calling those sys.argvs, and it's handling the conversion of data types for you. So it's always going to give them to you as text, but it's always going to feed it out back as text. That's why it's set parameters as text. I wonder what the values of, let me just see, if I run it from here, I get, yeah, those don't work. Well, it just printed nothing. So those values, there's nothing in A and B. Oh, it's equals in Python. I'm experimenting real quick. Yep, okay. So,
Dr. Raver?
yeah.
On the set parameters text, can you explain the 2, C again? I'm confused on the 2 part.
Okay. So, that's a good question. We'll go back to here. And actually, let's go back to, if I right click on this and say edit, oh no, that'll actually open up the Python. I meant to say properties. And then you go to parameters. So these are the parameters. And they're just in order. In fact, you can actually move them around if you wrote your script a little different. So this one right here, the top one, I'll just go over here because you guys can always see this. The top one, number 1, that's 1. This one is 2, and that one is, this one is 0, that's 1, and that's 2. They're just numbered from the top, starting at 0 though. 0, 1, 2. So over here, the first one we got it was 0, the second one is 1, and the third one we're assigning, so it's 2. It's just indexed. And then C is the value that we're going to feed it. That makes sense?
Yes.
So it looks like ArcGIS, if you don't specify a value, it's just an empty string. So if the reason why I did this is if A equals nothing, then you could print nothing. I mean, if A equals quote, you could actually say A equals 5.0, B, B. So the reason that I might do this right here is so that I can actually run this script. See, now I can run it from here and test it. Sometimes it's a pain to get things working in ArcGIS. So I ran it, and I actually might want to put print C here so that I could see it. So now I've got a script that'll run outside of ArcGIS. It'll print 15. And that same script will also run inside of ArcGIS. I'm going to choose a different number. I'm going to do 10 and 10. Watch, by the way, if I write 10 and I try to run this, I'm going to get an error. So ArcGIS handles, because I specified that this was a double, ArcGIS handled that error checking. I didn't have to do that. That's kind of nice. So I know that it has to, even though it's coming over as a string, I know that it has to be a number because ArcGIS is going to make sure it's a number before they pass it off. They'll also, like if you specify, give me the name of a shapefile, they'll also specify that it actually exists. So you don't even have to check that. It'll say that doesn't exist. If it's an input, if it's an output, it doesn't check if it exists. All right, so I'm going to say okay. It's going to run, and if I look at the result, it should say. It's hard to read, but it does say 20 right there. I don't know why my computer is so lame on the. ArcGIS is not very good at displaying, but that does say the sum is 20. Okay. All right, so we just created a simple, not very useful tool that actually runs. And I just put this part in. I'm going to comment this. This is so that it runs outside of ArcGIS for testing. Okay. All right. But you could also use this to establish optional values. So like if there was a value that was optional that they didn't specify, then you could put in the value that would be the default for an optional value. Okay. There's a few more concepts that I want to discuss before we move on to an actual more concrete example. And a few more, just the structure of the way you should do things. We've already talked about how everything's passed around as strings. The input and output types, we've only used the double so far, but in our next example, we'll use some other examples. But the thing that I wanted to talk about, actually I didn't put it in there. But the one I want to talk about is called Add Messages ArcGIS. Or ArcPy. I'm going to type in ArcPy. Oops. ArcPy. Sorry, add message, not add messages. Okay, ArcGIS add message will allow you can also add an error, but that's done less commonly, but you could actually make an error happen so that the user couldn't proceed. But a message will basically write something into the console, into the ArcGIS console. So let's do that right now. And it just takes one value, and that's the message to add. So let's, instead of, well, we can just write arcpy.addMessage and write the sum is. This is the syntax actually for, your book went over this, but we never covered it in class, but I'm just going to show it to you right here. here. Okay, so what I'm trying to say there is this syntax right here, what it will do is feed in this value into 0, and if you had another value, you could feed it in to something else. Okay, well here I'll show you that. I'll show you how. Well, let's make sure this runs. Save. I'm going to run it right here and see if it works outside of ArcGIS. It does. But the add message part, we don't get to see it. Well, if it runs inside of ArcGIS, see this line right here? The sum is 15. We added that in. That way we can, it's like a print statement, but you're printing for the benefit of whoever's using your tool in ArcGIS. So let's say your tool took like 15 or 20 minutes to run, and because it had a loop in it, and it was like overlaying lots of different data. You could output a message that said, now doing 1 of 5, now doing 2 of 5, now doing 3 of 5, now doing 4 of 5, and so on. So it's
That would be handy.
yeah, it's a way to feed out to the user what's going on inside of your script at that particular time. Sorry, I didn't mean to cut you off.
Oh, no, I was working with some LiDAR tiles, trying to mosaic them, and I let it run for 18 hours. It sure would have been nice to know it was still working and it wasn't frozen.
Yeah. So it's all depend on how that tool was created and if they wrote those in there. But yeah, it's always helpful to have that sort of information for the user to be able to have. And it does appear inside of here. It's hard to see, but it appears under messages. See how you can see the sum is 15. It puts it in there. Going back to here for just a second. So if I could change this a little bit. Okay, so the way that this format function works is you give it a string. Anywhere in your string where you have a squiggly mark and a number and a squiggly mark, you're going to replace it with the value that's inside of here. And you need to have exactly the same number of values that you're feeding in to squiggly bracketed things. So C is the first one, or 0, that's going to go in here. A is going to go in 1, and B is going to go in 2. So you can actually feed them in different orders. It's arbitrary, whatever you want. So this should work, although I'm not exactly positive because A and B are strings. So already it did work. The sum of 5 and 10 is 15. See, it worked. It's just an alternative. You could do it without those. And the way I've done it before, I've shown in this class before, is the sum of close quote plus a close quote, but it's longer. This is actually more succinct. So I just thought I'd show it real quick because the reason why I thought about it is because it showed up in the help here. I didn't want you guys to think, oh, what does that do? All right, there are a number of other tools that are for handling scripts. You can add an error, which will show up in red, and it will cause the script to end. So we could add an error in, and there might be a reason to do that. Let's say they provided it. Let's say you wanted to handle them providing a bad error, or it was running and there was some reason why it divided by 0 and you didn't expect it, you could add your own error in there. If you put in add warning, it shows up in a different color. I forgot what color it is. It might be green. But it'll show up in a different color, and it doesn't stop the script from ending. But let's say you were running like a statistical tool, and you could tell by the numbers that they input that they were violating some statistical principle, but it would still run. You could put a warning in that told them, sample size too small or something like that. Or sample size too small, make sure that you do something else. So I have used warning before. Add error is pretty rare, but I can see why you would use that. I already talked about get message count. If you run another tool, you can actually get the messages that tool, when that tool is running. But that's less frequent as well. All right. I don't even know what add ID messages is. Add ID message, I don't know what that does. I'm not sure. It's just yeah, I don't know exactly what that is. It's looks like something to do with an error in that situation. Okay. All right. So we're going to do one more example. There's one more thing to talk about, and that is when we create script tools, a few best practices. I've already indicated that I think most of the time you should check that box that says store relative path names. So that's my first advice. Related to that, I like to set up the structure of when I'm creating a tool. I like to save the toolbox in a directory, then save all the scripts that are needed to use that script in a directory called scripts. On top of that, if there are any resources that the scripts need to use, in other words, if they're using some data and they're always going to be using that same data, and that same data is stored locally, I like to create another directory called resources. So I have the toolbox itself. In a subdirectory, I have the scripts and in another subdirectory, I have resources that saves any data.
How do you create the subdirectories? Do you have to go into Windows Explorer?
Exactly. Yep. So and as long as you create them in those directories and you store relative paths, it doesn't matter if it's in the same directory or a path down. It'll still work. So right now we have them in the same directory. See, oops, that's not what I meant to do. This is what I meant to do. If I go to C temp and I go to SPA, I go to week 6, our toolbox that we just created is right here, and the script that we're using to run it is right there. There's no reason they can't be in the same directory, but I think it looks more clean to put the toolbox in the directory and then make everything about that directory the toolbox. And then have a subdirectory called scripts. So I would just right click. And I would call it scripts. But I'm not going to do that here because then I'm just going to clog up the GitHub directory. So that's the way I would do it. So you don't have to store it in the same directory. You can store it in a directory down. You can store it in 2 directories down. But I think it's easiest to transport if you keep them all together and you create a directory just for that purpose. All right. And then finally, the last best practice is that I like to get the script running outside of ArcGIS first, because it's a little bit harder to debug inside of ArcGIS. You can debug it in ArcGIS, but you'll always get those. You have to write print and add messages twice to make sure that it was working. And sometimes the error can happen because it's being run inside of ArcGIS. So if you get it running outside of ArcGIS and you know that it's working outside of ArcGIS, then when you run it inside of ArcGIS and it doesn't work, you know that it has something to do with how you created that script tool. Okay? So I get it running outside of ArcGIS. And in order to do that, I make sure when I'm creating my script that I set it up like this, so that I take my parameters and I have them all up at the top of the file because I'll need to get them from ArcGIS. And so I don't put, if this represents a single value, I don't put that all over the thing. Then I'll have to like cut and paste it all. Like if this represented, C:/temp/ArcGIS my shapefile.shape. I don't put that everywhere in here. Put that up at the top so that it's just a variable name, and then I can use it everywhere else. Use that same file everywhere else. So that's kind of what I was last week when we started doing that example, and I said, oh, this isn't good because I've cut and pasted that path throughout the file, and I rearranged it so that I just put the path once at the top. That'll help you when you go to actually write your tool up in our toolbox if you've written it that way, where the input is only listed once, and from then on it's handled as a variable. So that's the third thing I wanted to mention in best practices. All right. Now, I think we are going to take a break right now, even though we're going to do another example. And our other example is going to be more similar to an ArcGIS example. And then the assignment will be to take last week's script and just create our tool from it. So it will basically change it so that you could give it any two sets of data, and it would do that disaggregation process where it did the intersect. And so you need to feed it. We'll discuss and set it up, and you'll need to be able to feed it the information and then get a result. Okay. All right. So yeah, we're ending this a little bit early, but we're gonna be here for just as long. It's just that I think this is a better place to have a break. All right. So I'm going to stop it, and we'll just come back at